statement now. Apply pass1 and pass2 of 2-pass assembler to the following assembly language code and generate. Once again, here we need to generate what? Symbol table, literal table, if literals are available, and base table and pseudo table. Okay, so when you should require that base table or machine opcode table, and when you will require only symbol and literal table. Okay, so there is one thing related to this. Um, in pass one phase, okay, in pass one phase, using mnemonic opcode table, it is consulted to update the location counter. Mnemonic update opcode table means what? These instructions. Okay, these are the IBM instructions. Okay, I will provide you that PDF also for IBM instruction. For now, just consider this L means what? Load. This A means what? Add. ST means what? Store. Okay, DC you already know. Likewise. So when we are updating this column, that is, we need to add the location counter value in machine opcode table. Okay, MOT. Another one is called pseudo instruction. So when we are updating the location counter value for the second column, means for the machine values, then for start, for using, for LTRG is not there for this particular example. So for that purpose, we have to create machine opcode table. Okay, so let's directly solve it. So here I will write is the location counter value for machine instruction or mnemonic instruction. This is the location counter value for pseudo instruction. Okay, so let's start with what is label given. This example is given in your Donowen book. John, okay, John is the label. Then start 0. Okay, so what is the start 0? It is nothing but the location counter value. You need to start the next statement with the 0. What is the next statement now? We are not writing here anything. Okay, we are starting from directly from the mnemonic instruction. Okay, so blank. Now next statement is what? Next statement is using. Okay, using operand 1 is star means what? Location counter value is not given, but we need to assume it that is 0. Okay, and operand 2 is what? The register number value. Right? So what it says? It says the next instruction we need to start from 0th location counter value. Okay, because this is just the information given. Now let's start from 0. So I'll add 0 here. Okay, and this is the machine instruction. Here also I will add 0 because it is given already. Okay, now I am aligning this to the next statement. So what is the next statement? Load 1, 5. Now what is 5? 5 is my operand 2 and it is a symbol, right? So what we should do generally when we are having a symbol in our assembly language program? Yes?
S,
Symbol
0.
table.
Okay. Okay. So no S, 0 is there, but you are correct. When if we are solving by previous method, then S, 0 should be there. But if we are having some symbol, then you can directly add here. Okay, and no address because we are not declaring, right? So just add it in the symbol table, okay, with blank entry. Now tell me what kind of instruction is this? Whether it is ending with I? No. Whether it is ending with R? No. Right? Whether it is ending
No.
with, so which kind of instruction is this? So I can write here.
RX.
Very good. This is RX kind of instruction. So RX kind of instruction means the next instruction value should be incremented by, refer
4
that,
bytes.
yes, very good.
4.
Refer that PDF. 4. Okay. Now what about A? A is again
RX.
RX. So it becomes
RX.
8. Right? What about ST? ST is also RX kind of instruction. So it
RX.
becomes 12.
12.
Right? But see, what is DC? What is DC? DC
Pseudo.
is what?
Pseudo
Pseudo
opcode.
instruction. Right? Pseudo opcode. So can I write here in the machine? No. I should write in the pseudo opcode column, right? In the pseudo opcode column. And now I have to do the alignment. Now I have to do the alignment. Alignment for which constant? Alignment for F,
F.
4. Right? So I will write similarly here also. This is known as alignment. Now once again, what is the next statement? DC. Okay. Here I am adding this 4, 5 and temp into the, first of all, I missed that
Symbol
state.
table.
Symbol table 4, temp. Okay. Right. Now symbols are done. Now tell me, F is what? F is the full word.
Full
Right.
word.
So what will be the alignment here? 16,
16.
right? 12 plus 4. And here similarly I have to write the same thing. So first step is what? We need to add the address to the pseudo instruction, then we are aligning it to machine instruction. Okay, that is the step, main step. Now next thing is what? Declare storage. Once again the pseudo kind of instruction. Okay, so this is pseudo kind of instruction, and here we are writing or incrementing it by 4.
4.
Right? So once again do the alignment. Okay, after that next thing is what? Now DS is once again, here we can encounter 4, right? We need to increment the counter by 24. Okay, now end is again the pseudo instruction, so we are not aligning it. So that's all about the pass one phase. If we are solving with the, if we are solving with the IBM 360. Okay, now what are the addresses that we need to assign to all the symbols? Now we can assign all the addresses because we are having it in the machine instruction as well as in the pseudo instruction. So go to the symbol table. How many symbols are there? We forget about John. John is also there, na?
3.
John is also there, right? Okay, so what is the address of John? 0. Right? Address of John is 0 because it is starting from the 0th location. What is address of 5? Yes, tell me. What is address of 5? Yes,
16.
16. Okay. Now, what is address of 4?
12.
12.
Address of 10?
20.
20.
Okay. Now, what we have to identify? Whether they are associated with the pseudo instruction or relative instruction. Okay. So, this John is associated with the relative because I think it is a imperative statement, right? Relative. Again, this is also associated with the relative. You can see 5, 4, 10, load, add, and store. Okay, these are the relative addresses. So we can put here R. Okay, now we have completed with our symbol table. Now once again go to the table. Is there any literal available there? So no literal is available there. You can't find out equal to and quote, right? So no values. Okay, this is blank. Right? Now, think about the base table. Can we write anything in the base table? So yes. Why? Because using instruction is given here, right? So base table consists of 2 contents. One of them is register number and another one is what? Content. Okay. So what is the register number here? 15. Contents are 0. Okay, contents are 0 because star is given. Okay, if any instruction like this begin plus 2, then we need to add some value, but nothing is there. So basically it is 15 and contents are 0. Now where we are using those content? When we are generating the pass to phase. Okay, pass to phase of assembler, there we will require that content. Okay, that's why I am writing here. This content value is very important. Okay. So is this program consist of any pseudo instruction? Pseudo instruction in the sense end is not related to this because nothing to do with the end. Start, nothing to do with the start. Okay, using again address of the using is 0. That's why we are not generating machine table. Okay, or pseudo opcode table, sorry. Pseudo opcode table. So no pseudo opcode table is there. That's why here we can write. Okay, so this is very simple example. Now what we have to do? Now we have to go for the pass to phase. Okay, now we have to think about the pass 2 phase of assembler. Okay, now here we have given all the addresses. Once these addresses are correct, we have verified all these things. Now we are moving for the next. So from which statement this pass 2 phase will start? It will start from the mnemonic instructions. Okay, it will start from the mnemonic instruction. So write all the mnemonic instruction here. L. Okay, now what is the next thing? 1. Write 1 as it is. Okay, write 1 as it is. And 5. Now what we are doing with this 5? Okay, so here we have written the addresses for 5, okay, as 16, 12 and 20. While generating it, while generating the pass 2 phase of this address, let's open that PDF. Okay, so how we generate the machine code? So what I have given here, machine codes are generated if your statement will be like this: RR value 1 value 2 means operand 1 operand 2, then it should be written like this: operand 1 and operand 2. If we are having RX instruction like our program, if you are having RX kind of instruction, so what you generally do? RX. Okay, so here I have written RX. RX instruction is L. Okay, then value 1 is 1. I have written as it is, and offset value. Now what is this offset value? This offset value is nothing but your register, base register. Okay, so let's check out the base register. What is the base register number value? It is 15. And what are the content? 0. Now, is there any index? Index means what? If this statement, it will be like this, something like that, 2 or 3 or 4. That is known as the index of the base table, but no index is given. Okay, so what we can write here? Any index value. So any index value is 0 here, no index is given, and the register number. And the register number. Okay, so let's write it. It is 0, 15. That's it. This is the pass 2 code for IBM 360 370 assembler. Okay, let's move on to the next one. A, second value is 1. Again, here we are writing the offset value. Offset value is same. Means all the symbols, they are going to the same register, base register. That's why offset value is constant here. So 0, 15. The next one is what? Store. Okay, here I am writing ST1. Okay, and once again 0, 15. Right? Now we have completed with all RX kind of instructions. So here I will write it down for your understanding. RX. Okay. When you are solving it manually, if theory paper was there, no need to write this complete RX. Okay, just for your understanding. Okay, RX kind of instruction. Now our next phase is what? Here we are having the pseudo instruction, DC, DC and DS. Okay, and they are associated with some values. So we have to write all those values as it is. Okay, 4, 5 and nothing is there. That is F is given, nothing is there. Okay, why I have written 4, 5 as it is? Because it is given as the constant value. 4, 5 and black. So this is all related to pass 1 and pass 2 phase. Just look at the example carefully and tell me